Wireless LAN Professionals Podcast, episode 182.
But you also, inside the community, it's not just growing a community, but the individual persons have grown by, you put them in their uncomfort zone, you make them, you ask them to present, you ask them to do, deep dives, boot camps, stuff like that. And they're super nervous. They really take their time to prepare for this stuff. But then at the end, they come out as, much grown, people. They grow so much during the process, and it's such a nice thing to see.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Keith, I have another biggest struggle question for you. This is from Hitten, and I'm not sure if I'm pronouncing that correct, but Hitten. I'm trying to get my feet wet in the field of wireless networking. We are a Cisco shop with 28450 WLC and HA mode, 5000 AP, and biggest challenge is having no contention access and BW for students, faculty, staff, campus police, security devices, smart energy management, and building management, along with laundry machines on wireless network without a breach from each other's traffic. So it sounds like there's a lot going on in that question.
Starting with 5,000 APs, high availability mode, not having enough bandwidth. That sounds like a design issue. Nice that you have good hardware, and your APs that you mentioned were 2700 and 2800s, not bad choices. It's not the Cisco shop, it's not the high availability, and it's not even the bandwidth and contention. It's about wireless LAN design. You need to first know what your requirements are, and it sounds like you have requirements for students, faculty, staff, police, security, IoT devices, laundry machines, all those things. Those just need to go in as the inputs into your design process. I'm gathering, and I'm just guessing here, but I'm thinking your campus probably got to this solution over a long period of time. You start out with just a little LAN controller. You might have even started back in autonomous days, and then you added and added and added and added. And I doubt you've ever stopped and said, what are our total requirements? And then design to meet those requirements. If you don't have bandwidth, that's design. You can solve that with design. You don't have contention, as in I'm gathering you're saying you have too much contention, meaning your RF space is full. Well, if your RF space is full, again, that's a design issue. We can design with directional antennas, so you can have very, very high density. We can design with all the channels, DFS channels included. We can design all sorts of things to meet just about any requirements you want with the hardware and software that's available to us today in the wireless world. It sounds like your requirements have never been scoped and put down. And now, after the fact, people are saying, why is it not working? I have this device and it should be doing it. And you didn't ever stop. So a lot of campuses have been built this way. I've worked on a lot of edu that's got to exactly where you are today. And they just need to stop and start over. Not that you're going to do a rip and replace of everything, but you're going to stop and meet with the stakeholders, everyone who's involved who wants to use this wireless network, from the IoT all the way through the voice, or maybe the police need to do certain location tracking. Whatever the issues are, put them all on the table, build your list of requirements. And once you have the requirements, then you have to come along with a design and obviously a budget to meet that, and then a process to do it. It might take, with your 5,000 APs, a 2, 3, or a 4-year process to building by building, redesign, redeploy, revalidate, and make sure that it's meeting the requirements that you need. Or if you have the budget, it could just be one really big, long project that takes, a long summer or something. So, you've said you have a really big problem, and what your problem is the definition stage. The rest of the parts are just engineering. Coming up with getting everyone who's a stakeholder in the same place at the same time and agreeing on what they want, and then coming up with a budget. So this is a kind of a layer 8 issue.
WLAN interview.
Hello, this is Keith Parsons with Wireless LAN Professionals Podcast, and today I happen to be sitting in a, what year is this?
This is a 1971 Datsun 240Z. Is it like 3.5 liter turbocharged or supercharged? Yes.
Driving around in Helsinki with Mr. Jussi. How are you doing today, Jussi?
Oh, I'm doing fantastic whenever I see you, man. Good to see you again, Keith. It's been a good week. So yeah, doing good. And weather ain't bad either.
Yeah, weather in Helsinki is fantastic. But yesterday we were at the beach. Well, not really at the beach. We were at a conference facility called Beach 38 Degrees. I guess that's a good place to be at the beach. But it was indoors, and it happened to be something called Wi-Fi Design Day. First Wi-Fi Design Day, 2 years ago?
Yeah, something like that in the UK, correct.
UK. And so why did Ekahau get started with the whole idea of Wi-Fi Design Days?
Well, I mean, for us, it was like Twitter only reaches so far was the main thing there. I was looking at the Twitter stats like one day a few years ago and just going like UK isn't that strong on Twitter. And then we started talking about that with Open Reality, our UK distributor, and then started kind of brainstorming on what could we do. And then this is the end result. The idea was to bring the community together where otherwise they wouldn't. So where do bring a place. It was about setting up a place for the Wi-Fi minded people to meet locally, especially with a focus on non-Twitter covered areas. Because in the US, Twitter is strong, but elsewhere, not that much.
Yeah, and so I was at the first one. It was great. Actually, you had a really unique venue, the Churchill War Museum underneath, I don't even know what part of it was, right by the Thames. Great conference. A lot of people attended, and it was fun for the Wi-Fi people in the UK to get together and actually have a community. We kind of do the same thing with WLPC, but this is a one-day event and fairly inexpensive, and people like to come. We've had others like this, the Wi-Fi, sorry. WLA, yeah, there you go. Thank you for fixing it. Yeah. Have a couple one-day events that fit that same kind of need. Yesterday we had one in Germany. It was your first in Germany. Tell us about the attendance and what the conference was like.
Yeah, first of all, thank you. I believe you have been to all of our Wi-Fi design days, whether it's been Australia or UK or wherever. I think you've been to every single one presenting. So thank you so much. And I think that's been a big part of why they've been so successful. But how the Germany thing was, well, it was a case study example of a Wi-Fi design day in a sense that you're right, there's kind of similar events in a lot of places, but there's a couple of twists that we try to pull off as often as we can. One is a quirky, different venue. Like you said, we've had the bunker. We've had it at the bunker where Churchill used to head his troops during World War II. We've had it at a brewery in Australia. And now this time we had it at an indoor beach in... where was Munich. So, just try to get the quirky venue going. I think we pulled off that. Although, I heard you had some sand in your shoes and your laptop, but
But on the other hand, it was the only time I've been at a conference and I played beach volleyball during lunch.
That was epic. And Mikko has photographic evidence of you and me and several others playing beach volley. So that's that. Then we usually try to get the like good quality food, and then I think the main thing is like the best presenters. And for the presenters, we've had two qualities that we look after. One is outstanding technical knowledge, but the other one that's missing in some of these things is entertainment value of the presenter. How are his presentation skills? And that's what we try to combine those ingredients together. And thanks to you guys agreeing to come and present, like you and Peter and Steven and Tobias and Evelyn in this one, I think that's why they have been, every single one I think has been more or less sold out.
Yeah, and plus they had beach seats to sit in, so it was the comfy seats sitting out.
Exactly. I've never done a barefoot. I've never been barefoot on stage, but now I guess now I have.
Peter McKenzie got up and presented in his bare feet, so kind of a unique thing, and yet the topics were timely, on point, not just technically, but we learned about 6 gig and how 6 gigs both affect both the U.S. and Europe.
Yeah.
And as well as we got all 14 of Stephen's points of how to fail at Wi-Fi.
Indeed. And you did kind of similar topic to Stephen's, but a totally different angle. So I like how we, covered the important design aspects in 2 ways. Stephen's is how not to fail, and yours was like Wi-Fi always works except when it doesn't, kind of a theme there going on.
That was the exact theme. I did get a couple of comments on Twitter from people who saw the video or the pictures and said, what in the world were you doing with Legos? So maybe I need to turn that into something other. They're like, was that like BSS coloring? What was the point? So we might have to go and give a little better description.
That was real epic. I mean, the whole Lego thing really drives the point home, and it really throws people off at the same time. I mean, they get a little scared when you start smashing the Legos on stage.
I guess a podcast is a good place to explain this. What the Lego is trying to come up with an analogy to say we can have the same requirements, neg 67 everywhere. We need to have primary and secondary coverage and no co-channel interference and all of the data rate things we might need as requirements in Wi-Fi, and even have the exact same equipment. But when you install it, if you don't follow proper engineering rules, you're going to have a robust or a brittle network. So I use Legos as the example. Same requirement, same size model, exactly the same actual pieces of Lego. One, you follow the rules and overlap and make sure it's strong, and the other, you don't follow the rules and it falls apart very, very quickly. So for those of you who want to see the picture, it's on Twitter. You can go check that out. So what's next for Wi-Fi Design Days for Ekahau?
Well, that's the thing. We're still considering whether we should do a US one for example, in Silicon Valley or not. So that's right now under discussion. I think I have one of the US guys calling me today and discuss whether we should do it this year or next year. But that would be really interesting to have it in Silicon Valley, given that it would be a totally different audience. Within driving range, you have some of the many of the absolute greatest minds in the industry, but they have never touched Twitter. So you would get a totally, again, like a fresh set of people who are really into Wi-Fi, but to look at it from a different angle. They could be, RF engineers of Cisco. They could be software developers of Aruba. They
like Qualcomm chipset engineers. They would have some great views of how it works from the bottom side.
Exactly, or Wi-Fi guys from Apple and Facebook and stuff like that. So, that would be really interesting. Let's see if we have time to pull it off this year, or if it has to be next. But I'd be, really curious about that.
So the rest of Wi-Fi Design Days in 2019?
Singapore in, was it November?
November 29th?
You're going, right?
Yes.
And so am I. And also Australia. Did we agree on Sydney now, after all? I think so.
Sydney, December 6th.
December 6th.
But prior to that, there's another one in the UK. It'll be the third one in the UK.
Yes, where it all started from. And that one we've had annually, and I think we're going to continue. It's like doubled in size every year, and this was in Birmingham in November. So right. All of those are great. If you're in these areas and you want to attend, they're great. The other thing is, they have fantastic presentations, but you must be present to win, because they always give away prizes too. Yeah. Well, we just try to copy the WLPC prize giveaways, but we cannot match that. Hey, what about your stuff? So next up is October in Prague, WLPC, right?
Yeah, and so we're back in Prague. We actually, like all other WLPCs, we put out a survey and ask where we want to go, and the answer for this one was actually Tenerife in the Canary Islands.
Yeah.
And so that was the winner, and we tried to get it, but come to find out, to book a hotel that has that many people, you need more than a year in advance. So we tried, and all of the hotels that could handle us said, why are you calling this late?
Did you try the same hotel we did for Masters?
We did. That was my first choice.
Yeah, but still no.
But on the positive side, second place and only like 2 percentage points behind was Prague. People wanted to return to Prague.
Yeah, I've never been.
It was a great hotel, a great city. It worked really well. So we figured since it was second place, we'll do that, and we are booking Tenerife for a year out. So 2020 we'll have a Tenerife.
So when can we start looking at Prague in terms of registrations?
So the process for all WPCs is we send out a call for papers, and that just finished this week.
All right.
And then we put out a survey and we send it out to the audience. And about 2 weeks to collect the survey, about 2 weeks to collate it and get the answers. So we should have the survey going out mid-June.
Yeah.
By mid-July, we'll have the website up, and then we leave 30 days up for you to look at the website. And August 15th, the registrations go live.
Very cool. So what about WLPC and the call for papers? Any exciting ones that you're particularly excited about, since you know now?
Yes, I do. I don't want to taint the voting hasn't happened yet, so I'm gonna withhold. I don't want to tease you, because if I say what I'm excited, then people will probably choose something different.
Okay.
But we also have the deep dives, or what you can choose. We also have boot camps there. One nice thing at Munich, I had probably 4 or 5 people come up and say after hearing Peter talk, they want to come and hear the rest of his talk, and so they're coming to the boot camp of CWAP that Peter McKenzie will be putting on.
Nice.
And it's amazing. You can start building a community, and people like it. Some of the attendees at Wi-Fi Design Day in Munich this week came up and said, "Oh, I think I could talk," and they are submitting their papers. So I snuck a couple in right after the deadline.
Yeah, and that's really what really hats off to you. Not only is it like you've been the grandmaster of developing the Wi-Fi community. Of course, there's been other key people as well, but you played a key part of it. But you also, inside the community, it's not just growing a community, but the individual persons have grown by, you put them in their uncomfort zone. You make them, you ask them to present, you ask them to do, deep dives, boot camps, stuff like that. And they're super nervous. They really take their time to prepare for this stuff. But then at the end, they come out as, much grown, people. They grow so much during the process, and it's such a nice thing to see.
And actually, that wasn't really my goal, but it's been a fantastic net result of seeing this. I was just trying to share the load, so I didn't have to do it all. And the result is we get the community itself grows, individuals grow, and we all learn and share from each other.
Exactly. I hope the background noise isn't too excessive here. We are on a semi-highway somewhere in eastern Helsinki.
In Finland in the summer. But it's kind of a nice old-fashioned
talk about hitting
sports car.
2 birds at the same time. We are recording a podcast and taking the Datsun to annual maintenance.
That's what we do. We're trying to be as efficient as possible.
One more.
Yes, one more question. Go ahead.
Sorry, I know you were about to wrap up already, but one more event-related question for those that perhaps listened this far. Well, actually, this probably comes out after Cisco Live, but that's where I'm going tomorrow. Saturday morning, my flight leaves to San Diego for Cisco Live. You're not coming this year, right? But you've been there before.
I have not been to a Cisco Live, so that's kind of one of my goals. It's kind of tough, though, because it doesn't make me money. And so it's kind of hard to go to a conference that you have to pay for and lose your time and effort. I would gladly give my time to go and attend. I don't know about the money part.
Okay, for next year, we have guest passes every year.
I'll hold you to that one. Yeah, we'll work on it.
Probably doesn't get you in the sessions, but it gets you at least somewhere. In the venues and stuff like that. And
talk me into be a booth babe.
What's that?
You're trying to talk me into being a booth babe?
That's the grand plan.
I don't think I have the shape for it.
Hey, you never know. It depends on the preference. Look at me. Do I look like a booth babe to you? Yet still, there I am every freaking year.
But people love you. So, well, thank you for taking the time, giving me a ride in your classic Datsun sports car, and riding around in Helsinki and Munich. Wi-Fi Design Day was fantastic. If you live in any of the countries where these are, Singapore, Australia, or the UK, go for it. And hopefully, if we do get a US one this year or next year, we'll announce it.
Yeah, that should be fun. Sorry, not London, Birmingham this year, right? So it's in a bit different location. Should be a lot of fun. But thanks everybody for listening, and thanks Keith for coming in to our office for the week. You have been here for a week already in Helsinki, and for making the stop to Munich as well to present. Much appreciate that, man.
Thank you.
10 Talks.
All right. It was really great. I don't know if it was planned, but we had our friends from Comcast up here. I would have gone right after them. What they had on their presentation was a lot of the slides that I didn't have time for in mine. I kind of was hoping for a 30-minute slot, but that was great because all the actual screenshots from the test equipment and the analyzers and all that, that's what I don't have in mind, but what we're going to talk about is automating all that stuff. So it was really good that we would have been back to back. Hello, good afternoon, Phoenix. My name is Dale Hurshowy, and I'm an engineer for Shaw Communications. Best way to reach me, if you like, is through LinkedIn. Now, I know what you're all thinking, looking at me. You're thinking, why would Canada's leading connectivity provider, Shaw Communications, invest in the automated testing of access points, and how do they do it? That's a good question. We launched our business-managed Wi-Fi product around 5 years ago, and since then, the number of APs we manage for our clients and the number of AP models we support continues to grow. Not only that, but of course, the AP revisions from the vendors are never ending. We now manage over 50,000 access points for our business clients. Today, we'll highlight some of the benefits of automation and what type of testing you can do and what the architecture is. What are the benefits of automating testing? You can test OSI layers 1 through 7. You can expect consistent, repeatable measurements. It helps eliminate human error. Helps. You have minimal training to operate, though I will add having a really good understanding of Wi-Fi and testing is advised, so you make sure that your tests are running as expected. But you don't have to understand or memorize all the different configurations and all the different knobs and all the test equipment and software and on the AP that you're going to be testing on. You'll have time to do full regression testing. You can expect a dramatic increase in your test coverage because of it. And we saw a significant decrease in our cycle time. What used to take us around 6 weeks with 30% test coverage through manual testing now takes us around 2 weeks with 80% test coverage through automation. This slide outlines the OSI layers and the test coverage. Layers 1 and 2 can be tested through things like conducted emissions and receiver sensitivity tests. Layers 3 and 4 through rate versus range and throughput tests. And use case system testing can test layers 2 through 7. These tables illustrate our test coverage for transmit, receive, and link layer tests. On the left are the receive tests, the transmit tests, such as beacon power and spectrum mask. In the middle are receive tests like adjacent channel rejection and receiver sensitivity. And finally, link layer tests like rate versus range, throughput. Here's a diagram of system/use case testing that can test layers 2 through 7. This type of testing will allow you to test connectivity, both end-to-end and peer-to-peer, roaming testing, security such as walled garden, band steering, scheduling the periodic availability of your SSID, traffic shaping, and SNMP traps. This kind of test setup requires 2 access points and 2 clients. We've automated several, but not all of this testing yet. And for our clients, we used Raspberry Pis because we found them quite easy to program compared to smartphones, though my understanding is you can program smartphones if you require it for your testing. This is a diagram of one of our test setups, rate versus range. It's a relatively simple and inexpensive test to set up. The AP is inside one RF enclosure, and the client or clients are in another. Like all of our testing that we do, except for the use case testing, it's conducted testing with cables connected directly to the antenna ports on the access point. If you're working with an AP that has internal antennas, that does require a little surgery to make that happen. iPerf is set up on both the AP end and on the client, and then attenuation is incrementally increased. When the attenuation is low, your throughput, your signal strength at your client will be high and you'll have maximum throughput. But as you increase your attenuation, your signal strength will decrease and so will the throughput. The results can be graphed and compared, and it's useful to compare different AP models or different firmware revisions. This setup can test both uplink and downlink tests. It's been very helpful for us. I should point out what's already up there on the side. I do have a Butler matrix on the RF enclosure with the clients. Butler matrix is very important when you do conducted testing, as it allows you every receive path on the client to hear every transmit stream coming out of the access point, and it also includes a phase shift. So it's very good for conducted testing. These are real test results from our rate versus range testing. The red small dotted line represents APA, which we tested and looked okay. As you can see, when the attenuation is low, you have maximum throughput, and as attenuation increases, throughput gradually decreases. But how do you know if it could or should be performing better than it is? I created a way to make a theoretical plot based on transmitter properties such as signal strength, number of spatial streams, and channel bandwidth. The orange line is this. I don't know if it shows up on the screen there, but it's on the model. It's on the legend. The orange line is this theoretical plot, and in this case, it was very close to the results that we saw from APA, so we were happy with its performance. The purple line is APB. It's the one on the bottom. It's from the same vendor and has similar characteristics as APA. It's just a different model, but as you can see, it performs quite poorly. So when we took these results to our vendor, they came back and eventually gave us updated firmware, which when we retested that, and that's the blue line where performance came back to expected levels. This diagram represents our overall architecture of our automated testing. Robot Framework, or specifically RIDE, is the user front-end interface where you can select which tests you'd like to run and what settings you want to run with, such as access point, channel, and power. Python will have main measurement engines, such as the rate versus range test, as well as many smaller subprograms to control all the different test equipment and software involved in your testing. Robot Framework and Python are free. And then you have test equipment, which I say is the opposite of free. It can range from $1,000 or so for a programmable attenuator or RF switch to tens of thousands for a signal generator or an RF analyzer to hundreds of thousands of dollars for an Ixia variative chassis. And your AP, of course, needs to be controlled, be it through API, WLC, or web page dashboard. And a database is essential for collecting the large amounts of data that's going to be generated through your automated testing. The nice thing about automation is it allows for the automating of reports and pass-fail matrices, which would take significant time if you were to do those manually. From our experience, I wouldn't even suggest really starting the automation process unless you're willing to set up a database, because you're going to have a lot of data. This is a screenshot of RIDE, Robot Integrated Development Environment. It's the GUI editor for Robot Framework. In this example, it's the rate versus range test that we talked about earlier. On the left-hand side is where you can check off which test you'd like to run this time. And on the right are different parameters that you can edit if you like, such as iPerf settings or AP channel and power. This is a block diagram for one of our main RF test chambers. On the right is the AP with several jumpers for both 2.4 and 5 gigahertz. Then an RF switch to switch between the bands. Then some more splitters and attenuators. Then on the left, you can see a variable attenuator and another RF switch to switch between different pieces of test equipment that are outside of your chamber. On the bottom is a signal generator and RF analyzer. The signal generator can create both Gaussian noise and Wi-Fi signal and inject it both in the uplink and downlink. One reason why you might want to inject noise is to force your AP to transmit at a specific MCS rate. And the signal analyzer analyzes the signal from the AP for various different testing. Here's some photos of the front and back of that chamber that we just saw the block diagram for. And on the inside, you can see the AP sitting on top of the board, connected to a few jumpers. And all of the plumbing is underneath the board, and it is never touched as it's fully controlled through automation. And I'll add that you don't have to complete full automation right away when you start. If you start off with the right type of architecture, you can just begin with the basics. And then from there, you can refine your work and add more and more tests as time goes on. Thank you.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter at Wireless LAN Pros for all the latest news and updates, and also connect directly with Keith on Twitter at Keith R. Parsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.